Welcome to this video. We are going to take a look at something called diffraction. We will consider the different patterns produced from a single slit and also from two slits. Imagine we have a laser, and this laser is going to be aiming light toward there's the light, you can see it from the card. The light is bouncing off a first mirror, it's being redirected toward a second mirror, and then it's being redirected toward a slit. I've zoomed in now just on this slit that the light is bouncing onto. The slit is right here in the middle, and that slit is adjustable. So as we turn that knob at the top, the slit becomes wider or thinner. Now, after this beam passes through the slit, it travels a fairly significant distance, and it strikes this screen on the back, and it produces a spot. We are going to zoom in and look at that spot more closely, and we're going to watch how the spot changes based on changes to the slit width. We will start with the slit really big, and then we will close that slit, make it smaller and smaller. So here we are, we've zoomed in on that spot, and believe it or not, this is actually what you saw on the screen. It's hard to believe, but when we zoom in, this is what it looks like. Right now, the slit is quite narrow, and we're going to turn the knob and make the slit wider. So what happens to the pattern? When we make the slit wider, it does this. And now we make it a little wider and wider. So as we make that slit wider and wider, this pattern becomes more scrunched together. Let's watch that again in another video from MIT, but this time we're going to make that the widening, we're going to make it nice and smooth. So here it is. The width is increasing, and the pattern does the opposite. The pattern doesn't increase, it becomes more scrunched up. And eventually, all you see is that one spot. Now, there are a few things that we want to notice about these videos. To illustrate the differences, imagine we have three separate slits. The first looks like this, and the width of that slit is pretty big. The next looks like this, with a smaller width, and the final slit has the smallest of all. Let's take that first slit. When we send the light waves through, they spread out, not so much. If we then take the second slit, and we send light waves through, they spread out more. If we take the third slit, which is even the smallest, as we send light waves through, they spread out the most. So to summarize, the narrower the slit, the smaller the width, the more spreading out you get. There's another feature that we want to look at, which is this weird pattern of bright and dark spots. Here's the pattern that we saw formed on the back screen. I'm going to make a graph showing the intensity, or the brightness, at different points along this screen. So the Y value will be the intensity, which is just the brightness, and the X value is just the position. Right at the middle, at this position here in the middle, it's really, really bright, so we have a high intensity. Right here at this position, it's dark, so we have 0 intensity. Right here, it's bright, but it's not as bright as over here, so we have a lower intensity. The Y value, the intensity, is lower. Right here at this position, at this location, what's the intensity? It's 0 because there's no light there, it's dark. So we mark a data point, 0. Right here at this bright spot, again it's bright, but it's not as bright as this spot. This one is less bright. So the Y value, the intensity, is lower. Another dark spot, another bright spot, but not as bright, a dark spot, and a bright spot, but not as bright as the previous spot. This is dimmer than this. On the right side of the graph, we have the exact same thing. And if you want to pause the video, you can check to see that I've lined these up correctly. When we fill in the graph with a smooth curve, it looks like this. Let's take this picture and combine it with the one that we saw just before. Here's the somewhat larger width slit. The width here is a little bigger. You send light through, and it spreads out. But what do these arrows really represent? I'm going to let them represent the bright spots on the back screen. If you extend the arrows farther to the back screen here, then wherever you have an arrow striking the screen, that's where the intensity is big. The brightness is high. So here's the central bright spot, which is really bright, so high intensity. Here's the next bright spot, as shown by the intensity curve, and so forth. Here's the medium width slit, and again, this is the back screen, where the dot appears. If we send light through, it spreads out, and you see that the pattern then is going to be more spread out. We extend these arrows back, and now this is where you find the new intensity peaks. And the graph then is spread out, like this. Finally, with a really narrow slit, you send light through, and there's a lot of spreading out. But if we extend these arrows back, we could mark the location of the peaks. This is the most intense spot, directly behind the slit, and then right here, there's another peak. So before, we said this really vague thing. We said that the narrower the slit, the more spreading out you have. That's not very clear or precise when we talk about diffraction. A better thing to say is that this central peak, and then these fringes, as they're called, these fringes are more spread out in the case of a narrower slit. Now remember, in each case, this graph, this intensity graph, represents the bright and dark spots. So right here where the graph is high, you have a highly intense spot. Right here where the graph is 0, it's darkness. There is no intensity. Right here, when you look at the screen and you see the spot on the back, it looks like this. Wherever the graph dips to 0, that's darkness. Where the graph is high, that's a bright spot. And likewise, here's what the intensity pattern would look like on the back screen for this example. These patterns that I've shown here, here, and here, the pattern of bright and dark spots, are called diffraction patterns. They're also referred to as interference patterns. And it's easy to see that as we narrow the slit width, the diffraction pattern spreads out, the fringes grow in size, and they also become more spread apart.